Hey guys, we're going to do notes today over trig functions of any angle, and we need to focus on when the trig functions are positive and when they're negative in each quadrant. So if you remember your quadrants, this is quadrant 1, that's 2, 3, and 4. We have an acronym that kind of helps us remember when they're positive, and that is all students take calculus. And what that stands for is if you take the first letter of each of the words and you place them in the quadrants, starting with quadrant 1 and then go to quadrant 2, 3, and 4. So what those stand for is all trig functions are going to be positive in this quadrant. And then in the second quadrant, sine and its reciprocal cosecant are going to be positive in this quadrant. In the third quadrant, tangent and its reciprocal cotangent will be positive in this quadrant. And then in the fourth quadrant, cosine and its reciprocal secant will be positive. Okay, so let's do a few examples just to help you understand that a little bit better. Okay, this first example has us plotting the ordered pair negative 5, 12. So negative 5 is over here, 12 is somewhere up here. So this is a point. And that point is on the terminal side of theta. So if you've got a terminal side for an angle, that point right there lies on that terminal side. So what we're going to do is we're going to create a right triangle, because that's what we use when we've been evaluating our trig functions. So we're going to create a right triangle with this positive x-axis. The length right here on the x part of the axis is negative 5. The part right here on the y part of the axis is 12. And then we can use Pythagorean theorem if we want to. We can say negative 5 and square it plus 12 squared should equal c squared to get that hypotenuse. But this is also a Pythagorean triple, so we should know that that's 13, which we would get if we would finish the Pythagorean theorem. Okay, so here's our theta that we're going to be working with. So it wants us to find the 6 trig functions. We've got sine theta, which if you'll recall, that's the opposite over hypotenuse, so that would be 12 over 13. Then we've got cosine theta, which is adjacent over hypotenuse. So for this triangle, that would be negative 5 over 13. Then we've got tangent theta, which is opposite over adjacent. So for this triangle, that's going to be 12 over negative 5. And then we've got the reciprocal. So cosecant theta is the reciprocal of sine. So it's going to be hypotenuse over opposite, and it will be 13 over 12. Secant theta is a reciprocal of cosine, so it's going to be hypotenuse over adjacent. So it's going to be 13 over negative 5. And then cotangent is the reciprocal of tangent, so it's going to be adjacent over opposite. So it's going to be negative 5 over 12. Okay, so what we need to think about is our little quadrant thing that we did up there. We've got all students take calculus, and we've drawn this in the second quadrant. The only trig functions that should be positive are sine and its reciprocal cosecant. And if we look at all of our answers, this one's positive and this one's positive, just like they should be. So I'm kind of checking my answers with that. All right, let's move on to another example. Okay, in the next example, we have a little bit different. They're telling us that the tangent of theta is a negative 5/4 and cosine of theta is greater than 0. So if you'll remember what we just talked about, all students take calculus. They're telling us that tangent is negative. So tangent's negative in the second and the fourth quadrant. They're telling us cosine is greater than 0, so it's positive. And so that happens in the first quadrant and the fourth quadrant. So that kind of helps us narrow down to exactly which quadrant we should be drawing our reference triangle in. So what they both have in common is quadrant 4. So that's what we're going to draw our reference triangle. And when you do these triangles, you're always making it with the x-axis, and then it's coming from the origin right here. All right, so they're telling us tangent is a negative 5/4. Remember, tangent is opposite over adjacent, so this is our reference angle right here. And so when we do the opposite, it's going to be -5. The y's are negative here, so that's where the negative is going to be. The opposite, or the adjacent, is 4. And then we're going to have to use Pythagorean theorem to figure out what that hypotenuse is. So we're going to do 4 squared plus a -5 squared, and that equals c squared. So we get 16 plus 25 equals c squared. So c squared equals 41, which means c is going to be the square root of 41. Now this hypotenuse right here, it can never be negative because you're squaring those values, and so it will always make it become positive. So just something to remember. The hypotenuse, well actually I'll say it like this. The hypotenuse is always positive. Okay. So now it wants us to find all 6 trig functions. So we've got sine theta, which is opposite over hypotenuse, so it's going to be a -5 over the square root of 41. Now we're not supposed to have a radical in the denominator, so we need to rationalize that by multiplying the top and bottom by square root of 41, and that becomes a -5 square root of 41 over 41. So that's what the sine is. Cosine of theta will equal the adjacent over hypotenuse, so 4 over square root of 41. And again, you need to rationalize your denominator. And so that equals 4 square root of 41 over 41. Then you already know what tangent theta is. They gave that to you. And it's -5/4. Okay, so now I'm going to have to erase over here because I run out of room. Sorry about that. Okay, so remember cosecant theta. It's the reciprocal of sine. So I'm going to look at this part of sine right here and just flip it. So it's going to be the square root of 41 over -5. Or again, what you could have done was hypotenuse over opposite, if that's better for you. And then secant theta will be hypotenuse over adjacent. So it's going to be the square root of 41 over 4. And then cotangent will be adjacent over opposite, so it's going to be 4 over -5. So these are all of our 6 trig functions. And we should remember that in the 4th quadrant, the only thing that should be positive is cosine and its reciprocal. And so this one and this one should be the only ones that are positive, and they are, so we've done that correctly. All right, let's go up to another one. Okay, on the next one, we're saying that the sine of theta is a -4/5. So thinking through that, all students take calculus. The sine is negative in the 3rd quadrant and the 4th quadrant. Tangent of theta is positive, so that happens in the 1st quadrant and the 3rd quadrant. So the quadrant that we're going to focus on is quadrant 3. That's the one they share in common. So I'm going to make a right triangle. I'm going to make sure I'm using that x-axis as part of the triangle. And then I'm going to label it with the fact that sine theta is a -4/5. So that's opposite over hypotenuse. So if this is my theta, the opposite is a -4, the hypotenuse is 5. And then this is one of those Pythagorean triples. This would be a -3. And then also pay attention to the fact that in this quadrant, x's are negatives and y's are also negative. But again, the hypotenuse will always be positive. Okay, so then they're asking us to find the cosine and the cosecant of that angle. So cosine of theta will be adjacent over hypotenuse. So for this picture, it's going to be -3/5. And then cosecant theta, it's the reciprocal of sine. So it's going to be hypotenuse over opposite, which is going to be 5 over -4. And we've answered that question. Number 4 is saying to state the quadrant in which theta lies where sine of theta is less than 0 and tangent of theta is less than 0. So again, all of them are positive in quadrant 1. Sine is positive in 2, tangent's positive in 3, and cosine's positive in 4. So when the sine is negative is in quadrants 3 and 4, where tangent's negative is in quadrants 2 and 4. And what they have in common is quadrant 4. So that's my answer. Okay, on number 5, we're looking for the quadrant where cosine is negative, which would be in quadrant 2 and quadrant 3, and where tangent is positive, which is in quadrant 1 and quadrant 3. So what they have in common is quadrant 3. All right, let's do some more. Okay, now it's important for us to understand what a reference angle is. So a reference angle happens when we let theta be an angle in standard position. Its reference angle is the acute angle, must be acute, formed by the terminal side of theta and the nearest x-axis. It's always made with the x-axis. It is always positive and it's always acute. Okay, so that's what they're saying here. Theta has to be less than 90. If you're talking about degrees, should be a degree symbol there. And theta needs to be less than pi over 2 if you're talking about radians. That's what makes it acute. All right, so for example, if we have an angle in quadrant 1, this would be our triangle that we're going to form. This is our reference angle, theta, right here. Y's are positive in this quadrant. X's are positive in this quadrant. The hypotenuse is always positive. I'm going to remind us of that right here. Remember, hypotenuse is always positive. Okay, and we're going to be using Pythagorean theorem a lot to find that hypotenuse, which is what makes it positive. Okay, so if we're talking about an angle that ends up in the second quadrant, so what I mean by that, let me erase this for just a second. What I mean by that is that your terminal side's over here, so this is your angle. Well, this is the reference triangle that's formed. So this is where theta will be. And in this quadrant, the x's are negative, then the y's are positive, and your hypotenuse, again, is always positive. All right, so now let's look at it from the third quadrant. In the third quadrant, we have our terminal side here in the third quadrant, so our angle has come over here like this. So the reference angle is going to have to be formed by the nearest x-axis, and it'll be this angle right here. So this will be the right triangle that's formed, and that theta that we've drawn there will be our reference angle. And in this quadrant, the y's are negative, the x's are negative, and your hypotenuse is always positive. All right, let's do the fourth quadrant. So in the fourth quadrant, your terminal side will end up over here. So you've got an angle that went like this. So we have to form a triangle with a positive, or the closest x-axis, which is right there. So this will be our reference angle. Our y's are negative here, our x's are positive, and this is positive. So I'm going to fill all of this in real quick, and I'll come right back. Okay, so this is what it looks like for all of them put together. And what I want you to focus on remembering is that each of these angles for each of the quadrants, they're always forming triangles with these with the closest x-axis. I didn't use the y-axis at all. All right, let's do some examples. All right, we're going to first find the reference angle for each of these angles right here. So 105 degrees. Remember 90, whoops, I'm in the wrong color, sorry. Let me erase that. All right, 90 degrees is right here. This is where 0 degrees is, and 180 degrees is over here. So 105 degrees will be about right here. That's where the terminal side is for that angle. So it goes over like this to get 105 degrees. Okay, remember we said the reference angle has to be formed by the closest x-axis, which is this one right here. So this is where my reference angle is going to be. That's my theta. And so we've got to figure out what that actual measure is. So that is 180 degrees minus that 105 degrees, which gives me 75. So my reference angle for 105 degrees that I'm going to be using is 75 degrees. All right, for 372, remember this is 0, this is 90, this is 180, this is 270, and then when you go a full circle, that's 360. So it looks like to me we've gone a full circle and then another 12 degrees to put our terminal side right there. So this is our reference angle right here. This is our theta. It's formed by the closest x-axis and that terminal side. So to get the reference angle, we're going to take 372 minus 360, and we get 12 is our reference angle. All right, negative 120, that means we're going to go clockwise this time. So again, we're starting here at 0. This is negative 90. This is negative 180. So negative 120 will be over here. That's our terminal side. Theta, our reference angle, will be formed by that terminal side and the closest x-axis. So to figure out what that is, we're going to do 180 minus 120, and we get 60 degrees. Remember, your reference angle has to be positive. So we're going to say our reference angle is 60 degrees. Okay, 3 pi over 4. So now we're talking about radians. Remember, this is 0. This is pi over 2 radians. This is, this is pi, which is the same thing as 4 pi over 4. So 3 pi over 4, and I probably should say this pi over 2 is the same thing as 2 pi over 4. So 3 pi over 4 lies right here, halfway between those two. And so this angle would be 3 pi over 4. All right, and then we're going to make a reference triangle with that terminal side and the closest x-axis. This will be our reference angle right here. So to figure out what our reference angle is, we're going to do 4 pi over 4 minus 3 pi over 4 to figure out that our reference angle is pi over 4. So that's our reference angle. Okay, let's move on. All right, there are 3 special reference angles that we use to find exact trig values, and that's 30 degrees, which is the same thing as pi over 6. Remember, pi over 6, we can think of it as 180 divided by 6 to get that 30 degrees. So basically, anytime you see a 6 in the denominator, you should be thinking about a 30-degree reference angle. 45 degrees is the same thing as pi over 4. Anytime you see a 4 in the denominator, you should be thinking about a 45-degree reference angle. And then 60 degrees is pi over 3. So anytime you see 3 in the denominator, you should be thinking about a 60-degree reference angle. And what we're going to use those with is like when you have a 30, 60, 90 triangle, if you remember that from geometry. If your angle here is 30 and this is 60, and then you've got your right angle over here, the side across from 30 was your smallest side. It was 1. The side across from 60 was that side that was labeled across from 30 times the square root of 3. And the side across from the right angle was 2. When we did the 45, 45, 90 triangles, the side across from 45 was 1, the side across from 45 was 1, and then to get the side across from the right angle, we did those legs times the square root of 2. And you don't have to keep the 1s there, just remember it's a 1, 2 square root of 3 triangle and a 1, 1 square root of 2 triangle. All right, and then the 60-degree angle. So the side across from 30 is 1, side across from 60 was square root of 3, and the side across from your right angle is 2. Okay, we're going to use those triangles to find exact values of reference angles. I mean, you've memorized the unit circle, and this is just one more way for you to figure these out. Okay, so we're going to do sine of pi over 4, which, if you'll recall, that's just 45 degrees. We just kind of talked about that. So that angle is going to be right here. I mean, this is the 45-degree angle, or pi over 4 in this case. We're going to think about it as 45, though, because we know those values. So a 45, 45, 90 triangle. This is 1, 1, square root of 2. Okay, so if we're going to find the sine, remember sine is opposite over hypotenuse. So for that triangle, it's going to be 1 over square root of 2. We're not supposed to have square roots in the bottom, in the denominator, so we're going to rationalize the denominator by multiplying by square root of 2 over square root of 2. And so that simplifies to be the square root of 2 over 2. So that's what the sine of pi over 4 is. All right, now let's do tangent of pi over 3. So pi over 3 is a 60-degree reference angle, or it's just 60 degrees in general. So we're talking about this angle right here, that's 60 degrees. That's 30. This is your right angle. Remember, you always have to form those triangles with that the closest x-axis. So the side across from 30 is 1, the side across from 60 is square root of 3, and the side across from your right angle is 2. And so when you do the tangent, tangent's opposite over adjacent. So you're going to do the square root of 3 over 1, which is just square root of 3 when you simplify that. All right, let's do sine of 150. So remember, this is 0, 90, and 180. So 150 is going to be over here in the second quadrant. That's your terminal side. So we're going to make a reference angle that's formed with the terminal side and the closest x-axis. So to figure out what that reference angle is, I'm going to do 180 minus 150, and I get that that's 30 degrees. So this theta right here is going to be 30 degrees. So this is 60. So when we do our triangle, this is 1, this is square root of 3, and it's actually negative because that's where the x's are negative. And then that will be 2 for the hypotenuse. So when we do the sine, sine is opposite over hypotenuse, so it's going to be 1/2. All right, cosecant of 7 pi over 4. So we can either convert these radians to degrees. So remember, you'll multiply, if you're going to do that, you multiply it by 180 over pi and do that work. There's another way we can do this as well. First of all, knowing that right there, it has a denominator of 4, that tells me that I have a 45-degree reference angle. So I just have to figure out which quadrant I'm in. This is 0, this is pi over 2, and if I'm going to have a denominator of 4, that's the same thing as 2 pi over 4. This is pi, but to have a denominator of 4, this would be 4 pi over 4. This is 3 pi over 2, which is the same thing as 6 pi over 4. And then this is 2 pi, which is the same thing as 8 pi over 4. So 7 pi over 4 is going to be right here. And then it's going to have a 45-degree reference angle with that x-axis. And then remember, for your 45, 45, 90 triangle, this is 1. We're in that quadrant where the y's are negative. This is 1, and then this is square root of 2. So when we do cosecant, it's a reciprocal of sine, so it's going to be hypotenuse over opposite. So it will be square root of 2 over 1, which is just square root of 2. Except for, I just screwed that up, I'm sorry. Let me make that better. I forgot, we're doing opposite or hypotenuse over opposite. So it was square root of 2 over, but the opposite side's negative 1. So I should have made that negative square root of 2. I'm sorry. So one way to help check yourself whenever you're thinking through, did I just do that correctly, is to remember all students take calculus. And remember, we ended up in the fourth quadrant. The only thing that should be positive here is cosine or secant. So if I'm doing cosecant, I need to have a negative answer. So just something to help check yourself as you're working. Okay, on this next one, we have a denominator of 3. So I know that anytime it has a denominator of 3, that's going to be a 60-degree reference angle. I just need to think about which quadrant that's in. Or again, you can change 4 pi over 3 to be what it is in radians, or I'm sorry, to degrees. So 4 pi over 3 times 180 over pi, and you're going to get 240 degrees. All right, so you know that that's going to be in the third quadrant. Another way to do that is just using your pi over 3's. This is 0, this is pi over 2, this is 3 pi over 3, or pi, and so 4 pi over 3 is going to be over here in this quadrant, which is where 240 degrees would be. And then this is your reference angle, that's 60 degrees. Basically, if you do that 240 minus 180, you get 60 if you did it that way. All right, so using my 30, 60, 90 rules, the side across from 30 is going to be negative 1. The x's are negative there. This is going to be negative square root of 3, and then this will be 2. So the sine is opposite, oops, I don't know why I made that a theta, sorry. Sine is opposite over hypotenuse, and so we're going to get a negative square root of 3 over 2, and that's our answer. All right, for the next one, we've got 5 pi over 4. So 4 in the denominator, that means a 45-degree reference angle. pi is right here, which is the same thing as 4 pi over 4. So 5 pi over 4 is going to be right here. It's a 45-degree reference angle. So using that triangle, this is going to be -1 here, -1 here, and this will be square root of 2. And then secant is the reciprocal of cosine, so it's going to be hypotenuse over adjacent. So it'll be square root of 2 over -1, which is just a negative square root of 2. Again, check yourself by making sure that you have the right things positive in the right places. So we're talking about sine in the third quadrant on number 14. And the only thing that should be positive there is tangent. So this should be negative, and it is, so that's good. On number 15, we're in the third quadrant. And again, tangent's the only thing that should be positive, so this answer should be negative, which it is. Okay, let's move on. Okay, on this next one, we've got sine of -60 degrees. So you're going to go clockwise this time till you're 60 degrees. And then remember, your reference angle is always positive, and so you're looking at this reference triangle, where this is the 30, 60, 90 triangle. This is going to be a negative square root of 3. This will be 1, and this will be 2. Okay, so we're going to do sine, which is opposite, over hypotenuse, and so that's going to be a negative square root of 3 over 2. And in that quadrant, the only thing that should be positive is cosine. So we did good making it negative since we're talking about sine. Okay, now we're going to do -3 pi over 4. So this is 0. This is a negative pi, or in other words, a -4 pi over 4. So -3 pi over 4 is going to be right here. Again, you've got a 4 in the denominator, so that's a 45-degree reference angle. So this is going to be a -1 here, a -1 here, and the square root of 2 here. All right, so if we were to figure out this cosine, we're going to do adjacent over hypotenuse, which would be a -1 over the square root of 2. I'm not supposed to have a radical in the denominator, so I'm going to multiply by square root of 2 over square root of 2, which is a negative square root of 2 over 2. And that's your answer. And in the third quadrant, the cosine should be negative, so that's good. All right, on the next one, we've got 5 pi over 3. Because my denominator has a 3 in it, I know that's going to be a 60-degree reference angle. But again, if you feel more comfortable, change it to a degree. Change those radians to degrees. So 5 pi over 3 times 180 over pi, and that ends up being 300 degrees. So if this is 360 degrees, 300 degrees is going to be over here. You're going to make that triangle with the closest x-axis. And if we did 360 minus 300, we're going to get that reference angle is 60. So this is 60 right here. All right, so you're using a 30, 60, 90 triangle for that. So this is going to be 1, this will be negative square root of 3, and this is 2. We're talking about cosine, which is adjacent over hypotenuse. And so the adjacent side is 1, the hypotenuse is 2, and so my answer is 1/2. We're in the fourth quadrant where cosine is positive, so that's good that that's a positive answer. All right, tangent of negative 210 degrees. This is 0, this is -90, this is -180. So negative 210 is going to be over here in the second quadrant. If I do 210 minus 180, I get 30. So this is a 30-degree reference angle. So we have a 30, 60, 90 triangle. The side across from 30 is 1. The side across from 60 is square root of 3. And the x's are negative in that quadrant. And then this is 2. So if we're talking about tangent, that's opposite over adjacent. So it's going to be 1 over a negative square root of 3. We can't have a radical in the denominator, so we'll rationalize that by multiplying by square root of 3 over square root of 3. So we end up with the square root of 3 over 3. And that's our answer. Okay, on the next one, we have 7 pi over 6. This 6 in the denominator tells me it's going to be a 30-degree reference angle. Or I can change 7 pi over 6 to what it is in degrees by multiplying by 180 over pi. And I end up getting that that's 210 degrees. So that's going to end up in this quadrant right here. And if you did 210 minus 180, you get 30, also. So another way to get that 30-degree reference angle. So that's the 30, 60, 90 triangle. In this quadrant, the x's are negative, so this is going to be a negative square root of 3. This will be a negative 1, and this will be 2. Cotangents are reciprocal of tangent, so it's going to be adjacent over opposite. So we're going to do a negative square root of 3 over a negative 1, which is just square root of 3. And in the third quadrant, the tangents should be positive, and it's reciprocal, so that's a good answer. All right, on the next one, we've got cosine of 120. So this is where 180 is, 120 then will be right here. So its reference angle is 60. And so this is a 30, 60, 90 triangle. The side across from 30 is 1. We're going to make it negative in that quadrant. The 60 has the side across from it that's square root of 3, and then this is 2. So when we do the cosine, it's adjacent over hypotenuse, and so it's going to be a negative 1/2. And the cosine should be negative in that quadrant, so we did a good job. All right, that's all for those notes. Thanks, y'all.